This video is part of a series of videos around statistical process control. And I'll be pulling some content from the Lean Six Sigma data analysis workbook as we walk through the concepts. But for this video, the specific learning objectives are going to be taking a look at what a run chart is and how these time series charts can be useful for process improvement work and better understanding current and future state data. We'll take a look at how to interpret the results of run charts to make better decisions, how to use Microsoft Excel and the add in QI macros to build run charts. And then we'll take a look at some of the weaknesses associated with run charts. Well, it's an effective tool. There are some limitations, and we'll explore those limitations and how a follow-up tool called a control chart can help resolve some of those issues. Before we dive into the details of run charts, let me just paint a picture, I think, of where we're going with this concept of statistical process control. In the world of process improvement, understanding central tendency and spread, both for your current state data and future state data, is an important concept. And run charts give us a picture of that to help us to see data and the central tendency of that data over time. But then we'll find that there are more powerful tools called control charts that help us not only to see central tendency, but also help us to interpret and understand the spread. And then our final trip with statistical process control will be integrating run and control charts in a way so that you can look at current state data and then compare it to your future state data so that you can see if there was an improvement made to the system. And so that's where we'll be moving towards. First, let's focus in on what a run chart is. Well, in a nutshell, we're taking a look at a run chart right now. Run charts are simple time series charts that show process performance data where on the x-axis you've either got time, days, weeks, months, or occurrences that has been measured, and then the output from that measurement is on the y-axis. This is an example of a time series chart where we're taking a look at checkout wait times, and it looks like it's occurrence instances at this point. Typically, run charts will include, in addition to the plotted out data, you'll include central tendency, the average in this case, and they're a very effective way of understanding performance data. They can help with decision making. In a moment, we'll take a look at some of the things that I look for in a run chart. Things like runs, shifts, and trends. But first, what I thought I'd do is just show you how to create one of these run charts using Microsoft Excel's built-in tools as well as QI macros toolset. Okay, I'm now in Microsoft Excel and I've loaded up a data set that we use in our Lean Six Sigma data analysis program. It's related to the New Tech Wireless case. It's the call center student data set. And in the case, we've got some hold times from future state process improvement initiatives, the month of April, the average daily hold times, and that information I've got highlighted right here. And to create a run chart using Microsoft Excel natively with no add-ins or other statistical tools, it's very straightforward. I think it's one of the reasons why we see run charts used so frequently is because they're the tool set is easily available in Microsoft Excel. And here's how we do it. We go to the Insert menu, go to the Charts area, and I'm going to choose All Charts. And then from the list of available charts, I'm just going to choose Line Chart, and I'll press OK. And yeah, so there you go. It's pretty basic right now in the sense that it does not include a lot of details around what the x-axis is, which in this case is the day in the April dates, and the y-axis is the measured hold time in seconds. But it does give you the line chart that is characteristic of what we would typically call a run chart. Technically, a run chart also includes the average across the drawn across the middle here. And we could go back and calculate the mean and then insert a line in here. And that I'm just going to refer you to the help that's located in Microsoft Excel for tweaking X, Y axes and adding objects like a line. But one of the things that I like to do is I like to use QI macros to create a run chart. So now I'm going to compare the native Excel way to using QI macros. So let me get rid of this Excel chart. I've got my hold time data highlighted again, and this time I am going to go up to the QI macros menu, and I'm just going to go over to the submenu called Run Charts and choose the one in which the average using the mean is chosen. You could also choose average where median is calculated, but I'll choose mean. And when I do that, again, one click, super easy to do, but it's a little bit more detailed. You've now got automatically built in x-axis information, y-axis labels, and you've got the average drawn out for you. And that's going to be important when we use run charts to help us to understand shifts and trends. So having that average in there is important. But another piece that is often asked for is, hey, I'd like to also specify the specification limits. And we know from the case data that the specification limit for this case was anything that was under 110 seconds was meeting customer needs. And so wouldn't it be nice if we could also draw a spec limit? Now you could go in and use the Smart Shapes feature in Microsoft Excel and add that line to it. But QI Macros has got a special chart menu choice that once you create a QI Macros chart or once a QI Macros chart is created, this additional chart menu is available. And there'll be a separate video on all of these different features and capabilities, but the one that I wanted to just highlight right now with run charts is the fact that you can add a target line to the chart. And so I'll do that right now. And it'll ask, what do you want the label for that target line to be? And I'm going to call it the upper spec limit, USL. And then it asks what the target value should be. And in the case, we obtained that through some customer surveys, and it was 110 seconds or less. And so with that, now all of a sudden we've got not just the mean calculated in here, but we also have a spec limit, a frequently asked question. Technically, run charts do not include spec limits, and we'll talk later in this video on why including spec limits can sometimes be a trap, but it is frequently asked for, and so I just wanted to show you how you could do that. All right, now let's take a look at how we can use run chart data or run chart displays to interpret what's going on in the process that we're analyzing. All right, I'm now back in the workbook material from the Lean Six Sigma Data Analysis Program, and what I want to do is give you some tips on what to look for in the run chart data that you chart out. Three big things. We're looking for runs, shifts, and trends. So what's a run? So simply put, a run's a sequence of consecutive points that all lie on the same side of the mean or median line, and I've got that highlighted right here. And we've got run chart data. I've drawn a crude run chart right now where the blue line represents the mean. And when we're looking for runs, it's a sequence of consecutive points that all lie either below or above. Let's zoom in just a little bit and explain what runs are. So in this crude run chart example that I just drew, we're looking for changes that occur above and below the mean. So we've got 1, 2, 3, 4, this whole one here, 5, 6, 7, 8 runs total. And in this data set of, let's say that we collected 20 data points, we then compare the number of runs to the acceptable lower and upper limits for number of runs. And let's zoom out to take a look at that table. So if we did have 20 data points, I'd be expecting to see between 6 and 15 runs. And if I saw more or less than that, it'd be an indication that there is something unusual happening within the system. So there's an example of a run. Let's now take a look at another issue that I'm looking for in run charts. We call them shifts. So a shift is an example like we see right here, where there is a certain number of data points above or consecutive data points above or below the mean. And so an example of a shift. Another thing that I'm looking for are trends. Trends are the most common thing that I think people tend to look at when they're looking at run chart data, and you can have upward trends or downward trends. And again, whenever you see shifts, trends, or too many or too few runs, it's an indication that there is something unusual happening either in your current state data or the future state data that you're looking at. One of the things that I'm also taking a look at are alternating data points, sometimes called sawtoothing. And here is an example of sawtoothing, where we have one after another data point that's above and below the mean. So above, below, above, below, above, below, above, below, and so on. Sawtoothing or alternating. Those are the things that I'm looking for in run charts to help me better understand if there is something unusual happening in current or future state data. We sometimes call it special cause variation, and I will refer you to the separate video on common and special cause variation for more of a description of that. Run charts are an effective tool to help with the analysis of data. They're easy to create, they're easy to interpret and understand, but they do have some limitations. One of the problems that we see with run charts is when we introduce specification limits, there's a tendency for decision makers, process workers, and managers to assume that any time a data point is outside of spec that you should immediately go in and make some sort of corrective action or change. And one of the things that Sheward found back in the early 1900s and then was repeated with experiments over and over again, including Deming and the Deming funnel experiment, is that if you swoop in to make corrective actions without systematically understanding what caused that issue, or you don't have an understanding of the amount of variation that's inherent and natural in your system, you may have a process with a lot of variation, and you may have just experienced one of the data points that is a normal amount of variation, but it fell outside of spec. Going in and making a countermeasure corrective change could actually add more variation to the system. We need a tool that helps us better understand when it is a special exception or special cause, when a data point has fallen outside of spec, and when it is just an inherent issue with the amount of variability in the system, and we should take a look at some sort of systematic problem solving, process improvement to reduce the variation in the system through root cause analysis. The tool that we're going to look at next to help us spot whether or not variation is at play here is something called a control chart. We'll look at control charts next.